Hi again, let's start our first lesson. I have noticed that everyone starts this course differently, but I think it would be better for us to first focus on what we know and can observe from the universe at the present time. The first body that we'll observe within our vicinity is the solar system. But since you probably know about the dynamics of our solar system, I'm just gonna say a few things that are less commonly known. Our solar system ends with Kuiper belt, which edges around it. Its inner edge is about 30 astronomical units away from the Sun, and its outer edge, which is also our solar system's, is about 50 astronomical units away from the Sun. Now, according to NASA's website in March 2018, Voyager 1 is the furthest man-made object from us. It is about 141 astronomical units, and its sister Voyager 2 is about 117 astronomical units away from the Sun. That means we have made objects that have traveled twice or three times the distance of our solar system's radius. Which, if you think about it, is pretty damn impressive. The next set of astronomical bodies that we observe beyond our solar system are our neighbor stars. Our closest star system is Alpha Centauri. Alpha Centauri consists of three stars, two of which are Alpha Centauri A and B, which form a binary system and are 4.31 light years away from us. And a third one, which is gravitationally bounded to these two, is Proxima Centauri and is our nearest neighbor at an average distance of 4.22 light years away from our Sun. Us and all our neighbor stars are inside a larger astronomical body, which is called a galaxy. And the name of our galaxy is Milky Way, which you can see an imaginary picture of it right now on your screens. We still have not been able to photograph our galaxy physically at the moment. All the pictures you see of Milky Way are computationally made, and there is actually debate going on what exact shape our galaxy is. Also, the story behind the naming of our galaxy is quite interesting. I encourage you to do a quick search for it on the internet if you don't know it yet, but I don't want to branch out too much to keep these videos short. To start discussing our location and the physical properties of our galaxy. As you can see, we are not at the center of our galaxy, but are 8,000 parsec away from it. Since our galaxy is disc-shaped, the ratio between its dimensions is quite large also. There is 2 orders of magnitude difference between its diameter to its thickness. So if you imagine our galaxy to have a diameter of 1 meters, then its thickness should be about 1 centimeter. Now, if we zoom out a little, we will see that our galaxy is a part of a group of galaxies, or the local galactic group. There are 36 galaxies in this galactic group, and the closest galaxy to ours is Andromeda Galaxy, or M31, at a distance of 770 kiloparsecs at this very moment, which is also on course to crash with us in 4 billion years. And you can see very, very beautiful simulations of this collision on the internet. Now, our local galactic group is a part of a supercluster. This supercluster is referred to as VIrgo Supercluster. In general, the separation between the galaxies in the universe is about 1 megaparsec, and the space between these galaxies is referred to as intergalactic void. But as you may know, they are not really voids, since we don't really have such things in physics. But what you have to know is that most of the things that we can see and observe are bounded inside the galaxies. Now, once again, if we zoom out a little from our supercluster, we will see our neighboring superclusters. And as you can see at this level, the structures are losing their significance, and things are more or less looking more homogeneous. Now finally, our universe. So if we zoom out far enough, we will see that our universe looks smooth and homogeneous throughout. So this fact leads us to the modern cosmological principle, or as it is just known as the cosmological principle. Cosmological principle states that there is nothing special about our location in the universe, and that on large enough scales, our universe looks the same everywhere. So if you took every chunk of it, you cannot distinguish it from the other. And yeah, that's it for our first lesson. Please subscribe and like this video so that it can turn up in the search results for the people who might need it. And also, please read the notes that are linked in the description. And yeah, that's it. I'll see you in the next video. Bye. Bye guys.